Alrighty, in this video we're going to look at how to find slope using some points that are on the line. Again, in the bubble is a little review. Our slope is our delta y over our delta x. Okay, our delta y is our change in y. It's how many tiles are we adding or subtracting each time. And our delta x is over how many figures. We need those two bits of information all the time whenever we're finding slope, no matter what technique no matter what type of a line or which form of a line is given to us. If it asks us to find the slope, we always need our delta y and our delta x. Now, using points means it gives us two or three, usually 2 points that are on the line. Okay, and it says what's the slope of the line through these 2 points. Now what we need to understand is that points give us the same information about the line as a table. Because a table is just a collection of points, and finding slope using a table was very easy, so finding slope using a pair of points is also very easy. Okay, the points just give us the same information as on a table. Okay, the table tells us, where the line is, the points the lines go through, so if it gives us a point, it's the exact same thing as giving us a table. So if it says, find the slope through the points, and it'll give us 2 points. It'll say find the slope of the line through the points 3, 7 and 4, 13. Now again, what we need to understand is this information that's given to us from a pair of points is the same as the information that's given to us in a table. This point means figure 3 has 7 tiles, and this point means figure 4 has 13 tiles. So we still find delta y and delta x. We want to know how many tiles we're adding or subtracting and over how many figures. Now since points give us the same information as the table, the thing I like to do to get started is just turn these 2 points into a quick table. So we have figure 3 and figure 4. So we have figure 3 has 7 tiles. Figure 4 has 13 tiles. Okay, this point means figure 3 has 7 tiles. This point means figure 4 has 13 tiles. And that's the same thing. That's the same information that these pair of points gave us. Now we're used to finding slope given a table. Okay, we need our delta y. It's how many tiles are we adding or subtracting? Well, we're adding 6 tiles. Okay, from figure 3 to figure 4, we're adding 6 tiles in our delta x in this case. We're going from figure 3 to figure 4, so our delta x is just one figure. So this table is telling us that we're adding 6 tiles every figure, so our slope is 6 over 1, 6 tiles every figure, and then we reduce this to simply being 6. Okay, we're adding 6 tiles every figure, and that's what a whole number slope tells us. It's just like growth back in chapter 3. We're adding 6 tiles every figure, so our slope is just 6. Okay, let's look at another example. So let's find the slope of the line through these 2 points, 10, 2 and 5, 6. So again, these points simply mean figure 10 has 2 tiles and figure 5 has 6 tiles. We want to know how quickly is this line changing. How do we get from figure 5 having 6 tiles to figure 10 only having 2 tiles? What's the speed? How is this line changing? What's our delta y? What's our delta x? So to put it in a form more familiar, let's just turn it into a table. Okay, so we have figure 10 and figure 5, so we're just going to put them in order from least to greatest. Figure 5 has 6 tiles, and figure 10 has 2 tiles. So we're going from figure 5 to figure 10. So figure 5 has 6 tiles, figure 10 has 2 tiles. We still need our delta y and our delta x. Or our delta y is, well, we're going from 6 tiles down to 2 tiles. That means we're subtracting 4 tiles, and we're doing so, our delta x is every 5 figures. We're going from figure 5 to figure 10, so we're going over 5 figures, and we're subtracting 4 tiles. Okay, if figure 5 has 6 tiles and figure 10 has 2 tiles, that means we subtracted 4 tiles over those 5 figures. So our slope is simply our delta y over our delta x. Okay, it's the speed. We subtract 4 tiles every 5 figures. Okay, next example. Again, we're doing a lot just so we get comfortable and we realize finding slope given a pair of points is very easy. So let's say through the point 2, 5 and 14, 20. Again, these pair of points means figure 2 has 5 tiles and figure 14 has 20 tiles. So we want to know, how do we get from this point to this point? How do we get from this figure to this figure, from figure 2 to figure 14? So figure 2 has 5 tiles, figure 14 has 20 tiles. So we turn it into a little table, because again, tables are very easy to work with. Okay, they tell us that figure 2 has 5 tiles, figure 14 has 20 tiles, so we're going from 5 tiles to 20 tiles, so we're adding 15 tiles. And our delta x, we're going from figure 2 to figure 14, so our delta x is over 12 figures. We're adding 15 tiles over 12 figures, or every 12 figures. So our slope is 15 over 12, and we know by now that we need to reduce this. (15 over 12) reduces to 5/4. And again, at the very end, you want to make sure you get this sign of your slope. We're adding 5 tiles every 4 figures. Okay, this is positive because this line is increasing. This tile pattern is increasing. We're going from figure 2 having 5 tiles to figure 14 having 20 tiles. So we're adding tiles, so our slope has to be positive. In our previous example, our slope had to be negative because we went from figure 5 to figure 10. Well, figure 5 had 6 tiles and figure 10 only had 2 tiles. So as we go from one figure to the next, we're subtracting tiles each time. Okay, this tile pattern is decreasing. That's why our slope had to be negative. Okay, one more example together before you try a bunch on your own. So we have -2, 7, and 1, 7. Okay, here we're not really afraid of negatives. Okay, we just want to understand that we could have negative figures. So figure -2 has 7 tiles, and figure 1 also has 7 tiles. Okay, so there's two things in this problem we don't want to overreact to. Okay, that -2, well, we know how to deal with negatives. Okay, they're just the same as all the other numbers. So figure -2 has 7 tiles, and figure 1 also has 7 tiles. Okay, so we just want to know, how quickly is this line changing? What's our delta y and what's our delta x? Well, our delta y is how many tiles are we adding or subtracting each time. But if figure -2 had 7 tiles and figure 1 still has 7 tiles, that means our delta y is 0. Okay, we aren't adding or subtracting anything each time. We always have the same number of tiles. Okay, and our delta x, well, we're going from figure -2 to figure 1, so that's over the course of 3 figures. Okay, from -2 to +1 is we're adding 3. So if we're adding 0 tiles every 3 figures, well, this delta y equals 0 means, okay, we're not adding or subtracting anything. Okay, this tile pattern isn't changing. Okay, and this tile pattern isn't changing, that means our slope, which measures the rate of change, well, the line isn't changing. Our slope is just 0 over 3, which is simply 0. The slope of this line is 0. Okay, this tile pattern isn't increasing or decreasing, so we say the slope is 0. Okay, we're not adding any tiles, we're not subtracting any tiles. This tile pattern isn't changing. It will always have 7 tiles, so we say the rate of change is nothing. It's not changing, and that number is represented with 0. Okay, our slope is simply 0. Okay, so you're going to try 4 on your own, and you're just finding the slopes through each pair of points. And you're going to do so just by pressing pause once you see them all. Okay, so you're finding the slope of each line through each pair of points. So press pause, find your answers, and press play when you're ready to check. Okay, so again, we want to understand that this point means figure 8 has 13 tiles, and this point means figure 9 has 16 tiles. And we still need our delta y and our delta x. We still want to know how many tiles are we adding or subtracting and over how many figures. So figure 8 has 13 tiles and figure 9 has 16 tiles. Okay, we see that we're adding 3 tiles. If it helps, we make our little table. So figure 8 has 13 tiles and figure 9 has 16 tiles. That means we're adding 3 tiles, so delta y equals 3, and our delta x equals 1, because we're adding 3 tiles each figure going from figure 8 to figure 9, so that's each figure. So if we're adding 3 tiles each figure, then our slope is simply 3 over 1, which equals 3. We're adding 3 tiles every figure, so that means we have a whole number slope. It's just our slope equals 3. Okay, the example on the right, okay, figure 14 has 1 tile and figure 10 has 4 tiles. Okay, so we want to ask ourselves, how do we get from 4 tiles being in figure 10 to 1 tile being in figure 14? Okay, so how is this line, or how is this pattern changing? So figure 10 has 4 tiles, figure 14 has 1 tile. That's what these 2 points means. And when you're putting them into a table, you just want to make sure you're going from the first figure to the next figure. Okay, your x's want to start with the smallest and get bigger. We're going from figure 10 to figure 14. So our delta y, well, we're subtracting 3 tiles because we're going from 4 tiles down to 1 tile. So we subtracted 3 tiles, and our delta x is 4. Okay, if figure 10 has 4 tiles and figure 14 has 1 tile, that means we subtracted 3 tiles, and we did so over 4 figures. So our slope is negative 3 over 4. That doesn't reduce. Okay, we subtracted 3 tiles every 4 figures, and this slope is negative because, again, we subtracted tiles. This line is decreasing. We're losing tiles as we move throughout this pattern. Okay, and we can see that in the table. Figure 10 has 4, but figure 14 only has 1. So the tiles are decreasing. That's what we need to make sure that our slope at the end is negative. Okay, the bottom left example, figure 6 has 3 tiles, figure 14 has 7 tiles. So we want to know, how is this line changing? Okay, what speed at which are we adding or subtracting tiles? So figure 6 has 3 tiles. Figure 14 has 7 tiles. And we just make a little table to help us organize that thought, because we see that we're adding 4 tiles because we went from 3 tiles to 7 tiles, so our delta y equals 4. And our delta x, we went from figure 6 to figure 14. Figure 6 to figure 14 is 8. So our slope is we added 4 tiles over 8 figures. Again, 4/8 reduces to 1/2. Again, you want to check your signs. Okay, if figure 6 has 3 tiles and figure 14 has 7 tiles, well, just so you understand the situation, that means we're adding tiles. This tile pattern is increasing. As we move through this tile pattern, we're adding tiles, so our slope has to be positive. So at the very end, you want to make sure that your slope needs to be positive or negative. Just double check that you got the sign of your slope right by asking, is this tile pattern increasing or is this tile pattern decreasing? If we're increasing tiles, then it's a positive slope. If we're decreasing tiles, then it's a negative slope. This one we're increasing, that's why it's a positive 1/2. Okay, in our last example, okay, figure negative 3 has 0 tiles and figure 2 has 10 tiles. Okay, we aren't afraid of that negative number. Okay, you might think it doesn't make sense to have figure negative 3, which I guess is true, but we still want to understand that just thinking of it in that way helps us understand how to find slope. So figure negative 3 has 0 tiles, figure 2 has 10 tiles. So we want to know, how we get from one point to the next. What's our delta y? What's our delta x? How many tiles are we adding? Well, we're adding 10 tiles because we're going from 0 tiles to 10 tiles. So we're adding 10 tiles. And our delta x is, well, we're going from negative 3 to positive 2. So our delta x equals 5. Okay, we're going from negative 3 to a positive 2, so we're going over 5 figures. Okay, so our slope is our change in y, which is 10, over our change in x. We're adding 10 tiles every 5 figures, and 10 tiles every 5 figures is the same as 2 tiles every figure. So this is 2 tiles every figure, we just leave it as a whole number. Okay, 10 tiles every 5 figures means our slope reduces to 2. Okay, so if you need more examples, still refer to the textbook or some of the other online resources.